Hello, this is Susan Poss. I'm continuing to work in Chapter 8 on solving systems of equations. We have used graphing as our first method for solving. And when we graphed, we were looking to see where the common point of intersection was. Next, we looked at, in section 8.2, we looked at a process called substitution, where we solved one equation for a specific variable and substituted into the other one. And this time our third technique here is going to be called the addition-elimination method. And it rests on the principle of the addition property of equality, which says if you start with two equal quantities, and you see here I have A is equal to B, that if you add the same equal quantities to both sides, that the statement is still true. The left side and the right side are still equal. So that's what we're going to be doing, is adding some things together here. And the next thing I need to tell you before we begin is that the equations have to be in standard form, which means the x term must appear first, the y term in the middle, followed by the equals mark, and then the constant over on the right-hand side. We need these things in a particular order in order to add and eliminate a variable. All right, so here's what we're going to be trying to do. We're going to have a system of equations. Here you see equation 1, and here you see equation 2, and you see I have highlighted the negative y and the positive y. That's what we're going to try to be doing, is getting a single variable, either x or y, to match up in the numerical coefficient, except we want the signs to be opposite. And the reason we want the signs to be opposite is this is an addition method, so I'm going to be adding down the x column. 1x plus 1x is 2x. When I add down the y column, of course, that gives me 0y, which successfully eliminates the y, which is why it gets its name, adding/eliminating. And then adding down the constant column, I add 2 plus 8 to get 10, and dividing by 2, I get 5. So I've got the first number in the ordered pair. X is equal to 5. And just as you have seen me do, you can go back to either equation. I'm going back to equation number 2 because it has a plus instead of a minus. Doesn't really matter which one you go back to. I usually try to choose the one that looks easier. And there's the second number in the ordered pair. So we aligned these things so that there was an x column, a y column, and a constant column. We made sure that we had a variable where the numerical coefficients matched in number but were opposite in sign, so that we would get this to drop out right here in this spot. So that time we eliminated y to start with. Here's one where we're going to eliminate x to start with. And again, you can see that I've highlighted the positive 1x and the negative 1x. Everything is in standard form. Everything is in the proper position. So I'm adding down the x column, and of course that gives me 0x. So I leave a blank there. Negative 2y and positive 5y is positive 3y. And negative 11 and positive 23 is positive 12. And then dividing by 3, I have the first number, the y value, in the ordered pair. And I think I will go back to equation number 1. I don't know, one doesn't look much easier than the other one. And I will back substitute this y value, this y value, and I got 4 for y, so I'm substituting that in. So this is now x minus 8 equals negative 11, and adding 8 to both sides looks like x is negative 3. And again, if we were graphing these two lines, they would intersect at that point, negative 3, 4. All right, so scrolling on down, skipping over a little bit here. This one, I'm looking for coefficients that match on x or coefficients that match on y. I don't see that. I'm looking for opposite signs. I don't see that. So this one requires an extra step. I'm going to take equation number 1, and I'm going to multiply it by negative 5. Why am I doing that? What is 14 times negative 5? It's negative 70. Oops. Okay, so I took the first equation, I multiplied through the entire equation, all the way through, by negative 5. So you see all the signs have switched, and all the coefficients are 5 times greater, and the 14 is 5 times greater. All right, so here's why I did that. I was looking ahead, and I realized that if I left the second equation alone, don't do anything to it at all, that by multiplying that first one by negative 5, I would create a situation where I had the matching coefficients, but with opposite signs, so that when I add down the column of x, I will have that be eliminated. So I'm adding down here, I see a negative 17y as I add there. I see a negative 68 here. And as I divide both sides by negative 17, I think that's 4. I'm trying to do that in my head. I don't have my calculator handy. Yeah, that looks right to me. So the y value is positive 4. And then back substitute, equation 1 looks a little bit easier to me. So I will go in here. In place of y, leave that little spot there. Replace y with what we found, which was 4. And subtracting 16 from both sides. Looks like x is negative 2. Okay, so that one was a little bit different. We had to actually multiply through one of the equations by some number in order to get these coefficients here to be the same numerical value but in opposite signs. All right, so here's a challenging one. It's got decimal values in it, and there are a lot of ways to handle things with decimal values. I think what I will do is, first of all, just get rid of the decimals. And I hope you remember how to do that. I'm going to take equation number 1, and because these have tenths, I'm going to multiply by 10. That will simply move the decimal point one place to the right and give me all whole numbers there, so the decimals are gone. Same thing on the second one, I'm seeing tenths again. So right now, I'm not working on trying to eliminate anything. I'm just trying to get decimal points out of the way so that I don't have those more difficult numbers there to work with. All right, so times 10 on the first, moving decimals one place to the right, times 10 on the second, moving decimals one place to the right. So now I'm trying to decide what I want to eliminate. And I'm looking here, I'm seeing a positive 3y and a negative 6y. They already have opposite signs. So I'm going to take that equation number 1, which is now negative 15x plus 3y equals negative 72. And I'm going to multiply the equation number 1 by 2. All right, so that's what happens when I take the first equation and double it. So let me come over here and write this down again. Here's how this looks when I double it. And here's equation 2, and I'm going to leave it 30x minus 6y. I'm not doing anything else to that. And in my effort to eliminate the y variable, I have also eliminated the x variable. You see that I've got 0 plus 0 over there on the left-hand side. So I'm just going to write it down once. And on this side, I have 20. Excuse me, I have negative 20. And that is not true. 0 does not equal negative 20. All right, so when you come up, remember how you interpret this. Since we have something here that is not true, this means we have no solution. And again, if we tried to graph those two lines, they would be parallel, never intersecting. All right, so that's one of the special cases I wanted to show you there. What does it look like, again, when you have no solution? On this next one, this is another special case. And what I want to do here, let's see, what do I want to eliminate? I think I'm going to try and double this so it matches and multiply by -2 so that they have opposite signs. So here's what I'm going to do. Taking equation number 1, multiplying it by -2. So that's the first equation multiplied by -2. Here's the second equation, and I'm not doing anything to that. And again, my effort here was to try to get this y variable to drop out. But at the same time that the y variable dropped out, the x variable also dropped out, and the constant, -12, +12, ends up being 0. This is a true statement. Because 0 does equal 0. When that happens, you say this is a system that has infinitely many solutions. And you've seen this in previous videos, so hopefully you'll remember how to interpret these two situations. When you come up with something that's not true, it means no solution. When you come up with something that is a true statement, it means infinitely many solutions. All right, I've got one last one. I'm trying to move a little faster here. I don't want to have this video be too long here. All right, this is the last one. I wanted to show you this one because it's not in standard form. You see how things are all kind of scattered around. First one leads off with y, and then the x term is over on the other side, and it's just kind of a mess there. So the first thing you need to do here is put this in standard form. And remember, standard form leads off with the x term, follows with the y term, and equals the constant term. All right, so let me go over here for just a minute and work on this first equation. So this 10x is the thing that's in the wrong spot. So I'm going to subtract him off. Remember, here's your equals mark. I'm going to subtract him off the right-hand side. So it's going to say -10x plus 5y equals -30. So this is still equation 1, but now it's in standard form. So let me write it down. -10x plus 5y equals -30. That is equation 1. And here is equation 2. All right, so you've got to do that first. You have to get it into standard form first. Okay, so now I'm trying to decide what I want to eliminate. I can't just multiply one equation this time. I've got to multiply them both. So I think what I'm going to do is concentrate here on the y's And if I multiply the first one by 2, that would bring me to a 10y. If I multiply the second one by 5, that would also bring me to a 10y. I need the signs to be opposite, so I'm going to take the first equation and multiply it by 2. I'm going to take the second equation, and instead of just multiplying it by 5, I'm going to multiply it by negative 5, which is going to give me that negative 10y that I'm looking for. All right, so I'm sorry this one came out to be one of those special cases, because what I really wanted you to see there was that this standard form had to be attacked and dealt with first before you get it into a form where you can use the addition elimination. But as you can see, everything dropped out on the left. I got a negative 20 on the right. This is not true. So that means this one has no solutions. Okay, so I hope that's enough to get you started on the addition elimination technique.